We are going to now start talking about trig functions. So this video is going to be just to introduce you to trig functions. This should be review for you from geometry. This is something you've seen before, but we want to make sure and really get familiar with it since we're going to be using them a lot right now. Right here I've put the definition that the book gives you for what a trigonometric function is. They're always going to be used with right triangles, and we're going to use depending on what angle we're looking at, we're going to say that the side across from our given angle is our opposite side. The side next to our given angle is going to be our adjacent side, and then the hypotenuse, of course, will always be our longest side that is going to always be across from our right angle. Most people remember trig functions by using the term Sohcahtoa. And all that's going to be is it's going to be a trick to remember. If you're given an angle and you're asked to find sine, sine is always going to be opposite over hypotenuse. Cosine is always going to be the adjacent side over hypotenuse, because these trig functions are really going to be a ratio of your different sides of a right triangle, and tangent's always going to be opposite over adjacent. So I have them listed down here, the name spelled out, sine, as well as its abbreviation. Same thing with cosine, tangent. And then we also have cosecant, secant, and cotangent. So sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. Secant's going to be hypotenuse over adjacent. Tangent is opposite over adjacent. Cotangent is going to be adjacent over opposite. So Sohcahtoa is only going to help us remember our main three. We can then derive these from our main three. If you look closely, you'll notice that sine and cosecant are reciprocals of one another. We flip to find a reciprocal. If you think about how do I divide with fractions, you've probably heard the term flip and recip. That idea that a reciprocal is just flipping. Cosine and secant are going to be reciprocals of one another, and tangent and cotangent are going to be reciprocals of one another. So to answer this question, how are all these related? They're all reciprocals. So since they're all reciprocals of one another, there's many different ways I can think about how to define these functions. So I can define cosecant to be hypotenuse over opposite. I can also say that cosecant is equal to 1 over sine. I could also say that sine is equal to 1 over cosecant. We don't say that as much. We tend to want to write things in terms of sines and cosines if possible. I can also say that secant is 1 over cosine, and I can also say that cotangent is 1 over tangent. And like I said, I can also, and I forgot my angle measure there, so I'm going to erase that and re-put that on there. This variable here that I keep using is my theta variable. It's what we tend to use when we're talking about angles as opposed to side measures. We'll use a lot of Greek letters with our angles. I also want to give you an alternate definition of tangent and cotangent. Tangent and cotangent can also be written as tangent is sine over cosine, and cotangent can then therefore be written as cosine over sine. Right now we are going to use kind of these more main definitions here, but as we progress through, we're going to start transitioning, and we'll use these alternate definitions here more frequently as well. So let's go ahead and look at two examples. So the first example here, I'm actually given a picture of a right triangle. I have my right angle is going to be right here. I have this angle labeled as theta and this one labeled as alpha. So I'm going to go ahead and find my 6 trig functions. I think I actually have more than 6 here because I have a couple of them overlapping just to show how it works with a different angle. So first thing I'm asked to find is sine alpha. Sine alpha, so I'm going to do opposite over hypotenuse. So finding my opposite side, opposite's going to be across from it. So the opposite side of alpha is going to be 5. So opposite over hypotenuse, and like I said, you can use Sohcahtoa to help you with that. Now I'll have 5 over 6. Sine of theta, however, so is going to be opposite of that is going to be this side here. Well, notice I'm not given that side, but since it's a right triangle, I can find it by using the Pythagorean theorem. I can say that a squared plus 25 plus b squared equals c squared equals 36. So it looks like a squared is going to be 11. So I'm going to go ahead and this side is going to be the square root of 11. So sine of theta, and I'm going to kind of write it to this side because I didn't leave myself very much room, is going to be opposite, and my hypotenuse is still the same. So even though my opposite side changed, my hypotenuse will never change. The opposite side is going to be across from your angle. So if I'm at alpha as I was in the first one, opposite is 5. If I'm at theta as I was in the second one, opposite is square root of 11. If I proceed through the rest of them, I can see that cosine will be adjacent. Cosine of alpha will be adjacent over hypotenuse. So I'm at alpha, so the adjacent or next to side has to be square root of 11 because this has to remain my hypotenuse. So I'll have square root of 11 over 6 for cosine and tangent. And I'm going to alternate like I did on the other one and put this on the other side. Tangent of alpha is going to be opposite over adjacent. We've already talked about how the opposite side of alpha is 5. So I'll have 5 over the square root of 11, which I would then want to rewrite as 5 times the square root of 11. Maybe I will put this one back on this side for room. So 5 over the square root of 11, and I would multiply top and bottom by the radical 11, giving me 5 radical 11 over 11. Secant, I can either remember that I'm going to say secant is related to cosine. If cosine is adjacent over hypotenuse, secant must be hypotenuse over adjacent. Or because secant is the reciprocal of cosine, I can just flip my cosine. So I already know that cosine is square root of 11 over 6. So secant will be 6 over the radical 11, which is the same thing as 6 radical 11 over 11. Similarly, cosecant is the reciprocal of sine, and I already know that sine of theta was radical 11 over 6. I want to make sure and use the right one. So I'll have 6 over radical 11, or 6 radical 11 over 11. And finally, cotangent. I would flip tangent, but notice that I'm at theta here. I was at alpha, so if tangent is opposite over adjacent, cotangent must be adjacent over opposite. So if I'm at theta, adjacent will be 5. Opposite will be radical 11. So I get 5 over radical 11, which is 5 radical 11 over 11. And then we'll look at one more example. So we also not only need to be able to find our trig functions if we are given a triangle, we also need to be able to find our other trig functions if we are given one trig function. So what we'll do is we'll just create our own right triangle. We'll find our missing side and we'll name all the trig functions. So example 2, I'm told that sine is 1 over 3. So I'm going to go ahead and make a right triangle. I'm going to label one of my angles as sine. It doesn't matter which, or excuse me, as theta. It doesn't matter which. And I know sine is opposite over hypotenuse. So from my theta here, I'm going to go ahead and find my opposite side. That'll be 1. My hypotenuse will be 3. And then using Pythagorean's theorem, I'll have a squared plus b squared equals c squared, which tells me that b squared is going to be 8. So I'm going to have radical 8, which I know has a perfect square in it. So I'm going to go ahead and change that to be 2 radical 2. And now I'm going to go ahead and find my trig function. So I've got sine. If I find cosine, cosine of theta will be adjacent over hypotenuse. My adjacent is 2 radical 2. My hypotenuse is 3. I'm also going to find tangent. Tangent is going to be opposite over adjacent. So I'll have 1 over 2 radical 2. And then I'm going to go ahead and find cosecant. And cosecant, I'm just going to go ahead and flip my sine function. Secant, I will flip my cosine function and have 3 over 2 radical 2. Multiply top and bottom by radical 2 and have 3 radical 2 over 4. And then finally, finding cotangent, I'm going to go ahead and flip tangent, and I'm probably not going to have enough room there. I don't know why my writing is so big. And I'm going to say that tangent is going to be 2 2 radical 2 over 1, and I should have rewritten this a little bit better. I should have multiplied top and bottom by radical 2. If you don't understand any of my steps here, especially with the simplifying radicals, please make sure you talk to me about that in class, and I can show you that a little bit better.